Okay, let's solve another radical inequality. And again, if you see a square root with a variable in it and an inequality sign, you're going to follow these steps to figure out what x could possibly be. And again, this is going to be a range of numbers, right? It's not just one set number because of this inequality. So in other words, which numbers could we plug in for x to make this inequality true? You notice, for example, 3, we have two square root symbols. Let's read this. It's square root of x minus 1, the quantity plus 2 times the square root of x, all greater than 3. So, but fortunately, we've already gone over the steps to get this right. It's going to be the same steps we used for examples 1 and 2. We're going to set this inside of each radical equal to 0. So what does that mean? We're going to set x minus 1 equal to 0, and we're going to set x equals to 0. If x minus 1 equals 0, then x equals 1, and in the other one, x equals 0, coming from this one. So again, these are numbers we're just going to put on the number line for our test values. Step 2, change the inequality to an equation and solve the equation. Again, this just gives us our possible test values. We're going to change that greater than sign in the original question to equal, and we're going to solve. So there's some math involved here. This is solving a double squared equation, which we've gone over before, so if you forgot, go back and watch those lessons, ask me questions if you need to. You want to get one of the square roots on one side, move everything else to the other side. So we're going to subtract this 2 square root of x, move it over to the right, and now we have square root of x minus 1 is equal to 3 minus 2 square root of x. Once you do that, then you square both sides to get rid of the one radical. Okay, we're still going to have another one over here, but that's okay. So this is going to become x minus 1. This we will have to multiply by itself. So it'll be 3 minus 2 square root of x times 3 minus 2 square root of x. If we FOIL that, we get 9 minus 6 square root of x minus 6 square root of x plus 4x, because these square root of x's will cancel for the L and FOIL. This will become minus 12 square root of x, and then we'll move the 9 and the 4x over to the front. Next, what we're going to do is we are going to get this other square root by itself now. So it's kind of like a double-edged sword. So we got rid of this square root, now we have to get rid of this one. So we're going to subtract 9, move the 9 over, so at minus 1 minus 9 is minus 10. And then we're going to subtract the 4x from both sides to get rid of it. And x minus 4x is negative 3x, so now we have negative 3x minus 10 is equal to negative 12 square root of x. In fact, you don't have to divide by negative 12 because this is one term. So if we square it, it will get rid of the square root, and that's what we want. So now we're going to square both sides, and look what we have. That will cancel. That will become positive 144 because negative 12 squared is positive 144, and the squared will cancel. When we square the left, we have to multiply it out. Now, what's cool is you can pull a negative out right here and become negative 1 times 3x plus 10. We can see that negative 1 squared is positive 1, so it's just 3x plus 10 squared. And we can multiply that by itself. Let's 3x times 3x is 9x squared plus 30x plus 30x plus 100 when you FOIL it. And it becomes 9x squared plus 60x minus, plus 60x plus 100. This is a quadratic equation, so we need to get everything on one side now. See, this problem has it all, folks. So if this is overwhelming, go back and watch some of the lessons on solving double squared equations, solving quadratic equations. But by now you should be an expert anyway, right? So now we're going to subtract 144x from both sides, because in a quadratic equation you want to get everything on one side. So now we have to just do 60x minus 144x, which is negative 84x. Let me make sure I did my math right here. I'm just going to, okay. So now we're going to figure out a, b, and c. A would be 9, the coefficient of x squared. B is negative 84. C is 100. We're going to plug that into the quadratic formula, negative b plus or minus square root of b squared minus 4ac over 2a. Plug in negative b, that's negative negative, so it becomes positive 84. And then negative 84 squared minus 4 times 9 times 100. If we do the math here, 84 squared minus 4 times 9 times 100, we get 3,456. And just to verify that, folks, there it is right there in the calculator, 3,456. So now we want to take the square root of that in hopes that we can finally simplify this. So with this, yeah, because we are just dealing with, so these numbers right here are numbers, right? The question is, can we simplify square root of 3,456? Well, the answer is yes, we can simplify this, but for now, just because we're dealing with the number line, we can plug these into our calculator to figure out the decimal values. For the top, we have 7.93. For the bottom, we have 1.4. So that will give us something to put on the number line. Now, we've already figured out two test values, 0 and 1, so we're going to put these decimals on there as well, 1.4 and 7.93. So we have 0, 1, 1.4, between 1 and 2, right? And 7.93, which is right before 8. So that's step 3, placing our variable values on the number line. Now again, why are these holes? Because in the original equation, inequality, this is just greater than. It's not greater than or equal to. So I'm not going to fill those holes in. They're not going to be solid points, they're going to be holes. Now let's pick our test values. Anything to the left of 0 will work. So I'm just going to select -1. Anything between 0 and 1 will also work. So 1/2, obviously. Anything between 1 and 1.4, how about 1.3? Anything between 1.4 and 7.93, how about 2? Anything to the right of 7.93, how about 8? So we're going to plug those in, and we're going to plug them into the original inequality, this one right here. So let's plug those into the original inequality. We're going to plug in -1. We're going to plug in 1/2. We're going to plug in 1.3. And remember, wherever there's an x, you got to plug it in there. Might have to zoom in on your phone because this is so small. Getting this all on one slide. So yeah, plug in 1.3 here. Plug in 2 here, and then plug in 8. Those are all of our test values. So for the first one, we get the square root. If we plug in -1, we get the square root of -1. Obviously it doesn't work, so we know for a fact that this part will not be shaded over here. Next, if we plug in 1/2, again, 1/2 minus 1 is -1, and 1/2 minus 1 is -1/2, but we can't take the square root of that, so that means that this little part of the number line right here will not be shaded. How about between, how about 1.3? Well, this is going to be tricky. We get the square root of 1.3 minus 1 plus 2 times the square root of 1.3. I did the math in my calculator, and here, we'll walk you through that part. Okay, so that's what it looks like. Whoops, I gotta pull that back up. That's what it looks like when you type it into the calculator. You get 2.82, which is not bigger than 3. So again, for this little interval right here, between 1 and 1.3, not going to shade that part of the number line. If it worked, I would shade it. Next test value is 2. Plug that in. We know square root of 2 is about 1.4, so it's going to be the square root of 1, which is 1 plus 2 times 1.4. 1 plus 2.8 is 3.8, is bigger than 3. So guess what? This part of the number line between 1.4 and 7.93, I plugged in 2. I will be shading that. And finally, let's plug in 8. So we get the square root of 7 plus 2 times the square root of 8. Do that in your calculator and you get 8.3, which is indeed bigger than 3. So I'm going to shade anything to the right of 7.93 as well. So we're shading this little interval and this interval. So the thing is, when you get yes like this with 2 consecutive intervals, it makes you wonder whether or not that number where those intervals meet would work as well. So whenever you do have an inequality, in this case we had the greater than sign, not equal to, you do want to put the holes there like I said before, but when it looks like you're going to shade both the interval on the left and the right, you do want to check that number in between because it actually might work. Okay, and if it works, it doesn't negate the fact that there is a greater than sign here. All that will mean is that this number right here, which was 1.4 about, it'll still be a whole. So there will be one whole there. You're not going to have, you won't have a contradiction. The whole will still be there, but this could possibly be filled in actually. So what we're going to do is plug in 7.93 to see if it works. Alright, so I got my calculator out, plugged in 7.93 for x, and what do you know? You get 8.26. And 8.26 is bigger than 3. So what that means in this particular example, folks, is when we go to shade our number line, yeah, we do shade after 1.4, and we do shade after 7.93, but we're also going to fill that in. So what ends up happening is all you're doing is going past the 1.4. So the question though is, and I alluded to this earlier, can you actually simplify this radical right here? And the answer is yes. So right here, this number right here is our approximate 1.4. So how do we simplify it? Well, I did some playing around with the calculator. I kept typing in bigger and bigger square roots, and I figured out that 576, which is a perfect square, goes into 3456 6 times. So I broke it down that way. Square root of 576 is 24. And then you can actually divide each of these terms by 6. And here is our final answer, folks. X is bigger than 14 minus 4 squared root of 6 over 3, which again is approximately equal to 1.4. Let's go back to our original equation. So what that means is as long as I plug in anything bigger than 1.4 approximately into this equation, including for example 1.5, it will work and it will be bigger than 3. Alright folks, that's it for this example. If you have any other questions about it, let me know.